What does an asteroid impact look like? We can look at the moon through our binoculars and see impact craters with our very own eyes, but we didn't get to see them happen. And interplanetary missions send back images of impact craters from other planets, other moons, and even from asteroids. But again, we don't get to see the process of impact cratering. So from the craters, we don't really know what it looks like. Now, Earth, our own planet, is scarred by impact craters, and geologists have studied them in detail and tried to infer what an impact would be like. So we know for a fact that asteroid impacts happen, but they're very rare. They're very few and far between. They happen so rarely that we haven't had a big impact cratering event on Earth since humans evolved. So humans have never actually seen one of these things happen. But because the Earth's surface is so old and the moon's surface is so old, we have a record of those impact craters, and we can use supercomputers to model them. So it's really supercomputer modeling and the science of the understanding of the cratering process, and even artist rendering that help us really have an understanding of what an asteroid impact looks like. Now, there's a whole range in sizes of asteroid impacts. At one extreme, the big extreme, is the one we all know about, the dinosaur killer impact. And that happened 66 million years ago in Mexico. It was probably at least 10 kilometers in diameter. It came screaming in through the atmosphere, took maybe 2 seconds, a few seconds at most, to traverse the entire atmosphere, hit the ground, penetrate the ground, and explode. And it created a crater that's 150 kilometers in diameter. That's as big as the big island of Hawaii. The other extremes are smaller airbursts. The best example of that is the Tunguska event, the explosion over Siberia in 1908. It was actually on June 30th, which is why that's when Asteroid Day is. We put Asteroid Day on the anniversary of that event. And that did have eyewitnesses. Was really spectacular. It created a huge boom. It knocked down trees over an area spanning 2,000 square kilometers. The heat, the radiative heat from that event caught trees on fire. It charred the wood. So it was a very dangerous and big event. We think it was about 50 meters in diameter. The magnitude was maybe 5 megatons. So it was an enormous explosion, but very small on the scale of asteroid impacts. Now, the best witnessed asteroid airburst was the one also over Siberia, over the city of Chelyabinsk. And that was probably about a tenth as big in terms of mass and energy as the Tunguska event. That came through the atmosphere more or less sideways. It came at a very shallow angle, and there was an enormous explosion. It blew out windows all over the city. It injured over 1,000 people, and it was very frightening for everyone. But we don't have to just depend on the accounts of eyewitnesses because we have lots of video. A lot of people had these dashboard cameras in their cars, and we have many, many videos. They were starting to upload videos within a day of that event. So we really know what that looked like. And it matches our models very closely, which gives us a lot of confidence that we know what we're doing with the models. And artists have also depicted that. So fortunately, we're not likely to get hit by a big asteroid. We track them very well. We've discovered most of the big ones, but there's lots and lots of the small ones. And those are the ones we need to worry about the most. Those are the most likely. So what I hope is that we, with all our new telescopes, you know, the infrared space telescope that's going to come online, the Vera Rubin telescope, the LSST, with all of those telescopes, we will discover a smallish asteroid, one like the one that exploded over Chelyabinsk. Those hit the Earth, we think, roughly once every 50 years. We'll discover one on the way, and it'll be ready to come in over a very remote place. And we can actually send scientists and hopefully photographers and artists and watch that come in, and it will explode, and it'll be the most well-documented asteroid impact ever. And then we'll know what an asteroid impact really looks like.